Alright, this lesson today is inverse functions. So our learning target is I can find inverses of functions. I am so creative with these learning targets. Okay, so inverse functions, they're functions that undo each other. So if you think back to like when you were first learning to solve, I don't know, I'm going to make this up, x plus 2 equals 3. So what would you do to undo addition? You would do subtraction, because addition and subtraction are inverses of each other. Same thing if you had like 3x equals 6. So there's multiplication going on. You undo multiplication by division because multiplication and division are inverses. They undo each other. So it's pretty much the same thing. Oh, not that fast. Okay, so anytime you're talking about inverse, you're talking about how can you undo something. So here's the notation. Anytime you see this, you see f to the negative 1 of x. So remember, usually when we talk about functions, we just say f of x. Whenever we want to say an inverse function, we do to the negative 1. So anytime you see that, that means inverse of f of x. So sometimes they'll say, find the inverse of f of x. Sometimes they'll say, find f to the negative 1 of x. And you just have to understand that that means find the inverse. Okay, so let's look at these two. The blue is f of x equals x plus 2. And the green is f of negative 1 of x equals x minus 2. So they are inverses of each other. And so what I want you to see is what happens to the coordinates when you look at coordinates of inverses. What do they actually look like? Okay, so what we're going to do is we're going to replace the x in the blue with a negative 4. So what is negative 4 plus 2? Negative 2. What's negative 3 plus 2? Negative 1. What's negative 2 plus 2? 0. What's negative 1 plus 2? 1. What's 0 plus 2? 2. And what's 1 plus 2? 3. So that's how you do that. If you had a graphing calculator, you could put it in y equals and go to second table and you could get your table if you were a lazy bum. Okay, so same thing with the next one. I'm going to do the green side. I'm going to replace x with negative 2. So negative 2 minus 2, negative 4. Negative 1 minus 2, negative 3. 0 minus 2, negative 2. 1 minus 2, negative 1. 2 minus 2, 0. And 3 minus 2 is 1. I want you to look at these coordinates. What do you notice about the coordinates of a function and its inverse? So it went from negative 4, negative 2 to negative 2, negative 4. They went from negative 3, negative 1 to negative 1, negative 3. Hopefully you see a pattern. They're going from negative 2, 0 to 0, negative 2. From negative 1, 1 to 1, negative 1. From 0, 2 to 2, 0. From 1, 3 to 3, 1. What's happening with those coordinates? The x and y coordinates switch. That happens anytime you are dealing with inverses. The x and y coordinates are always going to switch. So if it was negative 4, negative 2, it will now have a point of negative 2, negative 4. That's just a really easy way to check yourself. Okay, so now we're going to take the same two functions, and I want you to graph them, and let's look at what do the graphs look like when we're doing inverse functions. So go ahead and draw one graph in blue and one graph in green so that you can differentiate between the two. Okay, so when you graph this, anytime you graph a function and its inverses, if you were to do like a dotted line right down the middle, a function and its inverse, the graphs should be reflected over the line y equals x. So that's that black line I just drew. It's a diagonal line. and the graph should always look like they've been reflected over that line. It doesn't mean that they're going to be parallel to each other. That was just this example, but they should always be a reflection of each other, a diagonal reflection. Okay, so the coordinate points are going to switch. The graphs are going to look like a reflection. And now let's look at some other stuff. So we're going to evaluate an inverse function. Okay, so I want you to pay attention. They give you this function right here. And we are going to find f of 2. So here's some weirdness that maybe you didn't pick up on in previous math courses. Anytime you have something like f of 2, you're saying the function being x squared minus 8x plus 12, the function evaluated for when x equals 2. So anytime you have a regular function, the number inside the parentheses is what x equals. So what I'm doing is I'm taking this number 2 and I'm plugging it in everywhere I see an x. So I have a 2, plugging it in, and I'm squaring it. Minus 8, plugging in a 2, plus 12. So you're replacing that x with a positive 2. If you like mental math, go ahead and do it. You can hear me typing on a calculator because I don't even trust me half the time. That answer is 0. That means that when we evaluate this function at 2, when x is 2, the y-coordinate is 0. So basically what you're saying is if the x-coordinate is 2, the y-coordinate is 0. Okay, so the same thing happens for the next one. F of 7, the original function evaluated for when x is 7. So I'm going to replace that x with a 7. And I'm going to get an answer. And I get 5. So what you're saying is when x is 7, y is 5. So let me show you another way to think about that. Let's go ahead and graph this function, that blue function. Go ahead and graph x squared minus 8x plus 12. Okay, so that's a horrible graph. But here's what we're saying. We should have the point 2, 0. And we do, in fact, have that point right here. Oh, a little... Okay, there we go. And then for the next one, we're saying we should have the point 7, that's not a number, 7, 5. And we do, right there, 7, 5. So remember, when we're talking about inverses, the coordinate points switch. So in the next one, I'm talking about the inverse of the function evaluated at -4. So in those first two, the number inside the parentheses was x. But because we're talking about an inverse, and we know that coordinate points switch, now we're talking about y. So here's what we're really trying to do. We're trying to figure out what is the x-coordinate when the y-coordinate is -4. So you're looking on your graph. What's the only point on there that would have a y-coordinate of -4? And it would be this one right here. That point is 4, -4. So, what is the x value when y is -4? Positive 4. Let's do another one. So we're going to do this one, f of -1 of -3. So usually, the number in the parentheses is x, but we're talking about inverses, so now it's switched to y. So we're trying to figure out what's the coordinate point. What would x be when y is -3? So we look on our graph. What's the only point in there that's going to have a y-coordinate of -3? And there's actually 2 of them. Right here and right here. So this point would be 3, sorry, this point over here, 3, -3, oh, this is getting ugly. And then this point is 5, -3. Let me just erase this one down here. So you're actually going to have 2 points because there's 2 points on the graph that have a y-coordinate of negative 3. X is 3 and x is 3 when y is negative 3, and x is also 5 when y is negative 3. Okay, so you're really just looking for coordinate points. And so these first two that we did, notice they didn't have the negative 1, so we were talking about just the original function. And then the last two we did, they have f to the negative 1. So they were talking about the inverse, which is why we switched the coordinates, because coordinate points of inverses switch. Okay, so let's do this one's the easiest part. I like this one. We're just going to find an inverse using only the equation, only the function. So there's 4 steps. We're going to change f of x to y. So that's number 1. So where I see f of x, I'm going to change it to y. Check mark, done. Step 2, I'm going to switch x and y. So the reason for that is anytime we have functions, inverse functions, we switch x and y. We don't switch anything else. The numbers stay where they were. We just switch the letters x and y. Check. Then we're going to isolate y. We're going to get it by itself. So the first thing I want to get rid of is that plus 11. What's the inverse of adding? Subtracting. So I'm going to have x minus 11 equals negative 3y. And then I need to get rid of the negative 3. The negative 3 and the y are being multiplied. What's the inverse of multiplication? Division. So I'm going to divide both sides by negative 3. So I got y equals x minus 11 over negative 3. Check. And then the last thing I'm going to do is I'm going to change my problem, change the y to f to the negative 1 of x. And that is because I always want to know that I've actually found an inverse. So f to the negative 1 of x, is equal to x minus 11 over negative 3. Now there are some different ways to write this, and I will count all of them, and we'll talk about that later. I just want to get the basics down. Okay, we're going to do the same 4 steps. First thing we're going to do is, if it says f of x, we're going to change it to y. Check. The next thing we're going to do is switch x and y. Check. The next thing is, I think, the hardest one. We're going to get y by itself. So I'm going to get rid of the minus 1 in the end. So I'm going to add it to the other side. People get stumped at this point. This is like a negative 1. You can just divide both sides by negative 1. So it's going to change both of those. And if you wanted to get rid of a square, you have to take the square root. And very important, we always put a plus and a minus in front of a square root sign. And then the last thing to do is I'm going to get rid of that plus 2. So I'm going to subtract. So now I have y by itself. Check. The very last thing to do is anywhere it says y, I'm going to change it to f to the negative x. F to the negative 1 of x. That is going to be my final answer. Alright, so I want you to try this one. See what you can do. I'm going to pause it in 1, 2, 3. Okay, so let's see if you got stumped or if you're okay. So the first thing I'm going to do is I'm going to change this to a y. Check. And then I'm going to switch x and y. Check. And then I'm going to isolate y. So I got to get rid of that plus 4. I got to get rid of the square. I'm going to square root it. Anytime you do a square root, you need to put a plus and minus sign in front of it. And I'm going to get rid of the minus 3 by adding. Y is isolated. The last thing I'm going to do is I'm going to change y to f to the negative 1 of x. And then write all the other stuff. Okay, so I did this a little fast. Remember, you can graph your original function and your inverse. Make sure that the coordinate points have switched. And you can also make sure that they look like they have reflected over that line y equals x. So that's a very simple trick to see if you understand it. Alright, don't worry. We're going to do some practice problems. You can contact me. Virtual learning is not that fun, but you're doing a great job. Please don't have a nervous breakdown. It is not that big of a deal. We will get through this together, I promise. Okay, bye.